This question is about the VI characteristics of a filament lamp. So we can see that it's about how current and voltage change for a filament lamp. And we've got here a graph of current against voltage, and we can see that there's a curve. The first part of the question says, draw a circuit diagram to show how you should connect the equipment needed to take the measurements to plot the graph. So the first thing we're going to need when taking any measurements in electric circuits is a cell or a power source. We're going to need to have an ammeter to measure the current, a voltmeter to measure the voltage, and we need to remember about the way that we need to connect them up. Now the other thing we're going to need, of course, is the filament lamp. And the last thing we're going to need is a variable resistor so that we can actually change the current and the voltage, because otherwise we'd only be able to take one reading and we wouldn't be able to get all the readings required for a graph. And so then we need to think, does an ammeter go in series or in parallel? An ammeter measures the current going through a wire, so it's got to be in series so that it measures that current flow going through. And then the last thing we need to connect is the voltmeter. And the voltmeter measures the potential difference across a component. And so we put it in parallel with the lamp. The next part of the question says the resistance of the filament lamp changes as the voltage is increased. And then it says, how can you tell this from the graph? Well, in order to understand this question, we need to know that R, the resistance, is equal to V over I. So the resistance is equal to the ratio of the potential difference or voltage divided by the current. And this comes from Ohm's law. And here we've got a graph of current against voltage. So we've got a graph of the gradient being I over V. And so this must be equal to 1 divided by the resistance. And so because we haven't got a straight line, we haven't got a fixed gradient. So because the gradient is changing, the resistance must also be changing. So we can just simply write the gradient is changing. And then it asks us to explain these changes in resistance. Well, so if the resistance is changing, that is because the longer you have the lamp on, the hotter it gets. So the first point that you'd write for your 3 marks is that the lamp gets hot. And what that means is that the electrons that are trying to move through the lamp, they start to struggle, because we know that if you increase the temperature, you're going to increase the vibrations. And so all the atoms that make up the filament start vibrating more and more. And that's much, much harder for the electrons to move through. And that's why the resistance increases. So the lamp gets hot, which then increases the chance of the collisions. So if you've got all these electrons colliding, then they're not able to move through the lamp, therefore it's harder for them to get through the lamp, and therefore the resistance increases. And we can see, going back to this idea about the gradient being 1 over R, the gradient is starting off very, very high, and then as you increase the voltage, the gradient starts to reduce and flatten out towards the top. So you can push more and more voltage, but you don't get much more current flow. And eventually, if you push more and more voltage, eventually the lamp would get so hot that it would melt the filament and no more current would flow, and this line would drop right down. So there you have it, 8 marks.